A process can appear perfectly stable because someone has become very good at rescuing it.
Man, it is such a striking thought, isn't it?
It really is.
Because it completely flips the way we usually look at a smooth-running operation. Whether that's a manufacturing line or, a hospital ward or a logistics hub.
Right. Think about that for a second.
Mm.
You walk onto your manufacturing floor or you look out over your open plan office and everything is humming.
The dashboards are all green.
Exactly. The dashboards are green, the daily quotas are being met, and you think you've designed a perfect system.
Yeah.
But in reality, what you might actually be looking at is a fundamentally broken system where someone is quietly sweating in the corner, catching falling plates, and just keeping the illusion alive.
Keeping the whole thing from crashing down.
Right. And that exact observation is the hook for our deep dive today.
Mm-hmm.
We are looking at a highly specific operational concept driven by a really fascinating source. It's Field Note 017, titled, "A Workaround is an Unpaid Process Designer."
And it's a document that really forces you to take a hard look at the unmeasured ecosystem of human effort in your workplace.
Yeah.
And we're going to explore this alongside some foundational research from safety science pioneers and operations management experts who have spent, honestly, their entire careers studying these quiet adaptations.
The things people do just to get their jobs done.
Exactly.
So our mission today is to completely change how you see the background hum of whatever workplace you operate in.
Yeah, we want to give you a new lens.
By the end of this deep dive, we want you to be able to recognize this hidden, undocumented compensation.
Which is everywhere once you start looking.
It is. We're going to explore how you can actually ask about this hidden work without sounding like, an interrogator looking for someone to punish.
Right, because that's the usual trap.
And we'll talk about how to properly record what you observe when you walk the floor. And crucially, how you avoid treating every single workplace workaround as either a stroke of rebellious genius that needs to be celebrated, or, on the flip side, a fireable misconduct.
Because there is a vast, complicated space between those two extremes.
Absolutely.
And that's where the real diagnostic value lives. We are jumping straight into the conceptual gap between how a process is designed on paper, in a pristine boardroom, and how that process actually survives on the floor.
In the muddy reality of the real world.
Exactly.
So if we are going to talk about workarounds, we really need to set some boundaries first.
Yeah, definition is key here.
Because the word workaround gets thrown around constantly.
Oh, all the time.
People use it when they talk about, hacking their home Wi-Fi router, or taking a back road to avoid highway traffic.
Or finding some loophole in a software subscription.
Right. But that's not what we're talking about here. What exactly counts as a workaround in the context of the operational processes we're diving into today?
We have to be incredibly precise with our language here because we aren't talking about a universal technical definition that applies to every aspect of life.
Okay.
In this field note, the term refers specifically to an undocumented action used to compensate for poor layout, unreliable information, or an awkward sequence.
Got it. So we're focusing strictly on goal-driven adaptations to organizational obstacles.
That is the core of it, yeah.
The worker is trying to achieve the goal the company set for them, but the company's own system has put friction in their way.
Yes. They aren't trying to, cheat the system for personal gain.
Right. They aren't stealing.
No, they are trying to rescue the system from its own design flaws so that the work can actually happen.
No.
And this brings us to an incredible framework developed by Eric Holmigel. He's a pioneer in safety science and resilience engineering.
Okay.
He formalized this entire dynamic by drawing a really sharp distinction between two completely different universes. He calls them work as imagined and work as done.
Work as imagined and work as done. Okay, let's unpack work as imagined first.
Let's do it.
Because this is where I think most management teams comfortably live.
Oh, they absolutely do. Work as imagined is the theoretical, illusory ideal state. It is what process designers, managers, auditors, regulators believe happens.
Or what they firmly believe should happen.
Exactly. When you look at a thick binder containing a standard operating procedure or, a beautifully mapped out color-coded flowchart in a boardroom presentation.
The PowerPoint slides.
Right, the slides. That is work as imagined.
It's essentially an alternative reality where friction doesn't exist.
Mm-hmm.
Work as imagined assumes that all resources are always available. It assumes the raw materials arrive exactly to specification every single time.
That templates perfectly.
Right, that workers are perfectly rested, that the ambient temperature of the facility never fluctuates.
That the software never has a microsecond of lag.
Yeah, is physics occurring in a frictionless vacuum.
Precisely. It is a sterile laboratory condition. But then you walk out of the boardroom and you have work is done.
Okay.
This is what genuinely occurs at what Honeygel calls the sharp end.
Oh, I love that phrase, the sharp end. It's so evocative.
It really is, right? The sharp end is the exact physical point where the work actually impacts the outcome.
So what does that look like in practice?
Well, if you are in healthcare, the sharp end is the needle entering the patient's arm.
Okay.
If you are in manufacturing, the sharp end is the cutting tool meeting the metal.
Right.
If you're in logistics, it is the forklift lifting the pallet. Work is done involves the fluid, dynamic, frankly messy reality of constraints.
It's dealing with the missing wrench.
Yes,
Yeah.
it's dealing with the ambiguous work ticket that is missing half the required information.
Or the software that crashes if you click 2 buttons too fast.
Exactly.
But, I can hear someone pushing back on this right now.
Yeah, I'm sure.
I can hear a frontline manager listening to this and saying, look, isn't adapting to your environment just what being a good, resourceful worker means? Like, we don't want robots. We want problem solvers. If a tool is missing, a good worker finds a way to get the job done.
And that is a very natural defense mechanism from management.
It sounds totally reasonable on the surface.
It does, but we have to look at the systemic cost of that assumption.
Right. The way I think about this distinction, to really visualize it, is to imagine an architect.
Okay, an architect.
Yeah. Picture an architect drawing up a pristine, gorgeous blueprint for a massive new skyscraper. That blueprint is perfect.
Yeah.
Every line is straight. The structural math is flawless. The tolerances are exact.
So that blueprint is work as imagined.
Exactly.
Mm-hmm.
But then, 6 months later, you go to the actual physical construction site.
Right.
It's been raining for 3 days straight, so the ground is a swamp. The steel delivery was 4 hours late. The crane is parked at a weird angle because the city didn't block off the street correctly. That muddy, chaotic, improvisational reality of the construction site is work is done. And the workaround is the undocumented bridge between the two.
That is a phenomenal analogy. The workaround is the worker laying down a piece of scrap plywood over the mud just so they can carry the steel to the foundation.
Right.
But here is the danger in that analogy. The architect sitting in the climate-controlled office never visits the muddy site.
They never see the plywood?
No, they never see the plywood over the mud. Months later, the building successfully opens. So what does the architect assume?
They assume the blueprint was flawless.
Exactly. The workaround successfully bridged the gap, but by doing so, it completely hid the gap from the person designing the system.
Wow. Which means the next building they design will have the exact same impossible constraints.
Absolutely.
And that takes us directly into the mechanics of invisibility. Like, how exactly does a glaring process defect, a gap in the blueprint, become entirely invisible to the people running the company?
Because it doesn't happen by magic.
No, there is a step-by-step logical progression to how systemic defects disappear from view.
There is, and it's a remarkably consistent pattern across industries.
Let's break down the mechanics.
All right. First, a defect or an obstacle occurs in the design process. Let's say we are looking at an assembly line, and a specific metal part always arrives at workstation number 4 with a slight jagged burr on the edge that shouldn't be there.
Okay, so the supplier didn't finish it properly.
Right. That is the defect. It is a failure of work as imagined.
Got it. So the part arrives flawed. Step 2.
Step 2, the operator actively compensates for that defect using their own effort.
Okay.
They know that if they load that burr-covered part into the machine, it will jam.
Yeah.
So the operator keeps a small metal file in their back pocket. Every time the part arrives, they quickly whip out the file, spend 6 seconds smoothing off the burr, and then load the part.
Wait, they don't fill out a defect report. They don't call engineering.
No, they just handle it because calling engineering stops the line, and their performance metric is based on keeping the line moving.
Of course it is.
Which leads directly to step 3. The final output continues successfully. The part is loaded, the machine operates perfectly, the finished product rolls off the line, passes final inspection, and ships to the customer.
And because that output is successful, we hit step 4.
Right.
That additional human effort, the pulling out of the file, the 6 seconds of sanding, it becomes an entirely embedded routine.
Yes. The operator doesn't even think of it as a workaround anymore.
It's not a deviation.
No, in their mind, it's just how the job is done.
If you hire a new operator tomorrow to replace them, the old operator will literally train the new one to bring a file from home.
Yeah, the workaround has metastasized into standard practice for the floor, even though it exists nowhere in the manual.
That is wild.
And that brings us to the final step, step 5, where the invisibility cloak is fully activated.
The invisibility cloak.
Observers and standard metrics only measure the final output. Think about the enterprise resource planning software, the ERP system.
Right, the software running the whole plant.
Your ERP system tracks inventory consumed and final products shipped out the door.
Yeah.
It is mathematically blind to the operator spending 6 seconds filing a burr because unpaid operator filing time is not a line item in the software's yield equation.
So the dashboards all look green.
Everything looks perfect.
The throughput charts show a 100% success rate.
Mm-hmm.
The defect and the rescue work are rendered completely invisible to anyone looking at a screen.
Totally invisible.
Management believes they are looking at a seamlessly functioning process, but they are actually looking at a continuously rescued process.
The field note we are referencing has a brilliant line about this.
Oh, I know the one.
It's a mandatory understated observation that just perfectly captures the irony of the situation.
Yeah, I love this quote. It has this dry, almost weary engineering humor to it.
Go for it.
The source says, the process report says everything is normal. The operator's walking route has submitted a minority opinion.
It's poetic, really.
It hits hard because it's so visual.
Yeah.
You can picture the pristine Excel spreadsheet showing 0 deviations, but then you walk out onto the floor and there is a deep, scuffed wear pattern worn into the concrete where an operator has been walking back and forth to grab a tool they shouldn't need.
Exactly. The paper says one thing, the physical environment is screaming another.
Right.
And if we pull on this thread and look at the broader academic research, the implications of this invisibility become genuinely alarming.
Tell me more.
Well, in our source stack, we have references to some seminal research by Anita L. Tucker and Amy C. Edmondson.
Okay.
They conducted a deep dive into operations management, specifically looking at frontline workers in hospital settings.
No, that's high stakes.
Extremely high stakes. They wanted to understand how nurses deal with systemic failures.
What kind of failures?
Things like missing medications, linens that weren't delivered, or incorrect patient information.
Right. A hospital is arguably the ultimate high-friction environment.
Yeah.
If something is missing, you can't just stop the assembly line.
Yeah.
There is a patient in the bed who needs care right now.
Exactly. And what Tucker and Edmondson found is that these nurses are incredibly, remarkably adept at what the researchers call first-order problem solving.
Meaning quick fixes.
Yeah.
Immediate patches.
Right. A nurse needs a specific gauge of IV tubing. It's supposed to be in the supply closet.
But it's not there.
It's not there. The nurse doesn't sit down and write a comprehensive procurement audit.
Right.
They sprint down the hall, go to a different ward, borrow the tubing from their closet, and get it to the patient.
They solve the immediate problem.
They are heroes. The patient gets treated.
Okay, so what's the issue?
Well, here is the tragic irony of first-order problem solving. Because the frontline workers are so incredibly good at bypassing these immediate failures, the system never feels the pain of its own incompetence.
Oh, wow. The signal doesn't travel up the chain.
It doesn't. The signal needed for second-order problem solving, which is the actual systemic correction of the root cause, like fixing the supply chain so the closet is stocked properly, it never reaches management.
Because the patient got better.
Right. The patient gets better, so the system assumes the process worked. Tucker and Edmondson call this state an illusory equilibrium.
An illusory equilibrium.
Yeah.
If you are a process engineer or a floor manager, that phrase should keep you up at night.
It really should.
Because it means the operational stability you're so proud of, the stability you get your annual bonus for, might be a total ghost.
Completely fake.
It's an illusion maintained entirely by the exhaustible, unmeasured energy of your frontline staff running around borrowing 5E tubing.
And we have to acknowledge that this is not a new discovery. This
Right.
isn't some modern phenomenon created by confusing software.
Not at all. We can trace this specific observation back decades.
Oh, yeah. Armand Feigenbaum.
Yes, Armand Feigenbaum, an American quality engineer. He identified this exact dynamic in the 1960s.
Mm.
He was studying a massive General Electric facility, looking at how manufacturing actually happened versus how it was designed.
And he coined a term that is still used today.
The hidden factory.
Let's talk about the hidden factory, because the sheer scale of what he found is staggering.
It really is.
Feigenbaum realized that beneath the official documented processes of the plant, there was a vast, unmeasured ecosystem of non-value-adding activities.
Like the filing of the burrs.
Exactly. The patches, the reworks, the quiet sorting of bad parts, the off-the-books adjustments.
Yeah.
These activities ran entirely parallel to the official process. It was a shadow industry operating inside the official industry.
And when he actually quantified the effort going into this shadow industry, he found that up to 30% of the activity in a plant can be part of this hidden ecosystem.
Up to 30%.
I want to make sure the listener really absorbs that number, 30%.
It's massive.
30% of the labor you are paying for, 30% of the time on the clock, 30% of the machine capacity is completely consumed by an undocumented ghost process that exists solely to compensate for defects in the main process.
And you are paying for every single cent of it.
Right.
But because none of it shows up on standard ERP systems or official performance metrics, you cannot see it.
And therefore, you cannot manage it or eliminate it.
Exactly.
Yeah, I think this is the perfect moment to pause and establish a really vital boundary for this discussion.
Good idea.
We have to be very clear about what we are not saying here. We are not asserting any motive or negligence by management.
No, not at all.
If you are listening to this and you manage a team, we aren't suggesting that your leadership is some malicious cabal sitting in an office actively conspiring to cover up bad process design.
No, absolutely not. The creation of a hidden factory is rarely born from malice.
Right.
It is almost always a natural, unavoidable consequence of how metrics are designed.
Okay, unpack that.
Well, if your operational dashboard is only programmed to measure final yield and throughput, then final yield and throughput become the only objective truth the system knows how to recognize.
Ah, so the system isn't evil. It's just mathematically blind to its own realities.
Exactly.
It's like trying to observe the wind by looking at a thermometer. You just have the wrong instrument.
That's a great way to put it.
So the obvious question becomes, if you are a leader, an engineer, or just someone who wants to understand how your workplace actually functions, how do you pierce through that illusory equilibrium?
How do you find it?
Yeah, how do you actually get a glimpse of the hidden factory?
Which brings us to the diagnostic tool at the center of this source material.
The central question.
Yes. In the field note, there is one exact, beautifully calibrated question designed to break this open.
Okay.
If you want to see the gap between work as imagined and work as done, this is the exact question you ask the person doing the work.
Let's hear it.
What do you do here that is not written down?
What do you do here that is not written down? Let's really deconstruct the wording of that question, because every single word in that sentence is carrying a heavy psychological and diagnostic load.
It is so deliberately phrased.
Why is this specific phrasing so useful for you, the listener, if you want to understand your own operations?
First, look at the orientation of the question. It asks about objective, observable conduct.
Right.
What do you do? It is not asking about subjective feelings or emotional states.
Like, it's not saying, are you frustrated with this machine?
Right, or do you feel like this process is inefficient? Those questions invite complaints.
Which can be useful.
They can be, but they don't give you mechanical data. Asking what they do anchors the conversation entirely in physical reality and mechanical steps.
Yes, and second, and this is perhaps the most critical aspect of the phrasing, it does not begin by accusing the operator of a violation.
Exactly. Contrast it with how managers usually approach these situations. Imagine a manager walks up to a workstation, notices someone doing something odd, and says, "Why are you doing it that way instead of following the manual?" Or, "Why did you skip step 3?
Yeah, what is the immediate biological response from the worker?
The walls go up instantly.
The fight or flight response kicks in.
The operator goes into defensive mode because they assume they are being reprimanded.
Right, they assume they're about to be written up for non-compliance.
But asking, "What do you do here that is not written down?" completely flips the premise.
That's so.
It implicitly assumes that the written document is incomplete, rather than assuming the operator is misbehaving.
Oh, that's brilliant.
It creates a safe, neutral space to reveal the gap between the written document and the performed work.
Now, I have to jump in here and represent the skeptical listener for a second.
Please do.
Because there is a massive inherent tension here that we can't ignore.
What?
If I'm a floor worker and my boss, the person who controls my schedule, who decides my annual review, who has the power to fire me, walks up to my stadium with a clipboard and asks, "What do you do here that is not written down?" My immediate survival instinct is going to flare up.
Of course.
I'm going to assume this is an audit trap.
Yeah.
I'm going to look him dead in the eye and lie. I'll say, "Nothing, boss. Everything is exactly by the book. I love the manual."
And that is a highly valid, incredibly realistic concern.
Right.
If it sounds like a trap, if it feels like a trap, the answers will naturally become shorter or they will become outright fabrications.
You'll just get silence.
Yeah. We cannot claim that this question is some magic spell that always produces honest or complete answers on the first try.
Right. It's not a silver bullet.
Its success depends entirely on the observer's unthreatening delivery and, frankly, on the pre-existing culture of trust within the organization.
The source material presents this as a writer-developed suggestion, right? Not an explicit foolproof instruction.
Exactly. It's a tool, but like any tool, it matters how you swing it.
So how should someone deliver this question?
Delivery guidance is paramount here. You have to ask this question calmly.
Calmly.
You have to ask it in context while standing there in the actual physical work environment, not sitting across a desk in a sterile office.
Right. Go to the sharp end.
And you must remain intensely curious rather than corrective.
What happens if you get corrective?
Well, if an operator bravely admits, "Well, I actually use a piece of scrap metal to pry this lever because the handle's too stiff," and you immediately pull out a red pen and say, "That's an OSHA violation, stop that immediately,"
Oh, no.
you have just guaranteed that no one in that facility will ever tell you the truth again.
Yeah, you burned the bridge. You have to earn the right to the information by proving you won't weaponize it.
Exactly.
Okay, so let's say you ask the question properly, or you're simply conducting a silent observation of the floor, and you spot something. Let's walk through 3 strictly hypothetical illustrations to help train your eye. That sounds great.
For each of these scenarios, we are going to break down what you see, the observation, what it might mean, the possible interpretation, and crucially, the evidence you still need before you take any action.
This is a great way to put the theory into practice. Let's look at the first scenario.
Okay.
A tool stored away from the point of use.
Let's hear the observation.
Here is your observation. You are standing on the edge of the floor watching a process flow. You notice that an operator regularly stops what they are doing, walks 20 feet to an entirely different station to retrieve a specific specialized wrench, brings it back, performs a single action, and then returns the wrench.
Okay.
They do this repeatedly every cycle.
Now, the immediate uncalibrated managerial instinct is going to be frustration.
Oh, absolutely.
You see someone walking instead of working and you think, why is this person wandering around? They're wasting cycle time. Go tell them to stay at their station.
But if we apply our new diagnostic lens, our possible interpretation changes completely.
Right.
They have to assume the worker isn't just walking for the fun of it.
Exactly. The possible interpretation is that the official workstation layout is inconvenient, or it was poorly designed for the actual physical sequence of the work.
Whoever drafted the blueprint for this station didn't realize that this specific wrench was necessary for this specific step.
Precisely. The walking route is the minority opinion pointing out a flaw in the workstation design.
I love that.
But, and this is a massive but, we cannot jump to conclusions and immediately start bolting new tool racks to the floor.
Right, because we don't have all the facts yet.
We have separated the observation from the interpretation. Now we need the third piece, the evidence still required.
We still need to ask questions.
Exactly. Is this specialized wrench a highly expensive shared resource that belongs to the whole floor, meaning they literally have to walk to get it?
Oh, that makes sense. Or was the wrench that usually lives at their station just temporarily misplaced today by the previous shift, making this a one-off event?
Yes. Or is this 20-foot walk the permanent, undocumented routine that happens 100 times a day?
We have to investigate the context before we redesign the floor plan.
Exactly. Let's move to the second hypothetical.
Okay, what is it?
This one is very common in highly automated environments. A displayed status that the operator independently checks.
Oh, interesting.
Here's the observation. You are watching an operator monitor a process. There is a digital control system, a multi-million-dollar sensor array that clearly flashes a bright green light on a screen, mathematically declaring that a metric is reliable.
Like a dashboard.
Right. It says the internal temperature of a vat is perfectly safe or the pressure in a pipe is normal.
Okay.
But you observe the operator ignoring the green light, walking over to the vat, and visually or manually verifying that exact metric themselves before proceeding.
Wait, how?
They physically tap an analog gauge or they open a small hatch to look at the fluid level with their own eyes.
This one is fascinating because it strikes at the heart of the human-machine interface.
It really does.
The possible interpretation here suggests a deep systemic issue. The formal control, that expensive, state-of-the-art digital sensor, is not trusted by the floor staff,
Why wouldn't they trust it?
usually due to historical inaccuracies.
Yeah.
Maybe that sensor has a known lag, and the operator knows from bitter experience that when the screen turns green, it actually takes another 30 seconds for the pressure to truly drop to a safe level.
All right.
If they trust the screen and open the valve immediately, they get sprayed.
Exactly.
So the workaround is their manual analog double check.
It's a protective mechanism.
Wow.
But again, we must identify the evidence still required. We can't just assume the sensor is garbage.
True.
Has the sensor recently failed and they are just being overly cautious today?
Or has it been unreliable for 3 years and engineering has ignored the maintenance requests?
Yes. And crucially, is the operator's manual double check actually more accurate than the system? Or is it just an embedded superstition passed down from a previous worker? Right? Like maybe the old guy trained them to do it that way and they don't even know why. We don't know the reality until we investigate.
Exactly. Let's look at the final one.
Let's do it.
Hypothetical 3. A sequence the operator quietly reorders.
Here is the observation. You are holding the official standard operating instruction sheet.
The manual.
Yes, the manual. It clearly lists the assembly steps in order. 1, 2, 3, 4, 5.
Right.
But you stand back and watch the operator, and you notice that they smoothly, routinely, and without hesitation perform step 4 before step 2.
They are rewriting the code in real time.
Yes.
The possible interpretation here is usually physical. It suggests that the prescribed sequence on the paper does not match the physical realities or the environmental conditions of the actual work.
Right. Doing step 2 first might make step 4 physically awkward or harder to reach or ergonomically painful for the human body.
The official sequence might look perfectly logical, clean, and sequential on an Excel spreadsheet. But when applied to three-dimensional space, it forces the worker to bend their wrist at a terrible angle.
The human body is rejecting the work as imagined.
That's a great way to say it.
But the evidence still required is absolutely critical here, especially regarding safety.
Why safety?
We have to ask, does this reordering happen every shift? Does every operator do it, or just this one specific person?
Right.
And most importantly, does reordering those steps inadvertently skip a safety check built into the original sequence?
Oh, wow. I hadn't thought of that.
Sometimes a sequence feels clunky because it was intentionally designed that way to force a physical cooling period or to ensure a specific part is locked in place before power is applied.
You know, I want to pause here and make something very clear for the listener about how we are discussing these scenarios.
Yes, this is important.
We are using exactly these 3 examples,
Yeah.
and they are strictly hypothetical illustrations. We are not going to invent a tidy Hollywood outcome for them. We aren't going to tell you a neat little story about how discovering the reordered sequence saved a company $1 million in cycle time.
Or how the manual sensor check prevented a massive chemical spill and saved 10 lives.
Right. The source material doesn't provide those convenient, definitive resolutions, and neither should we.
The point isn't the outcome. The point is the discipline of the observation itself.
Yes. The point is separating what you see from what you assume.
And that restraint is vital. Because if we assume every workaround leads to $1 million savings or saves a life, we fall into a very dangerous trap.
There is a massive tendency in modern business literature, and on LinkedIn and in management seminars to romanticize the hero worker who hacks the system.
Oh, we love that story.
We absolutely love the narrative of the maverick on the factory floor who ignores the out-of-touch corporate suits, throws away the manual, and gets the job done their own way.
It's a very seductive narrative.
It is.
It feels good. It feels like human ingenuity triumphing over soulless corporate bureaucracy.
It does. But we have to inject some rigorous nuance here. A workaround is not automatically a best practice. Just as we previously established, it is not automatically a fireable misconduct.
Right. It is simply a signal.
So let's look at the 4 distinct possibilities of what a workaround might actually represent when you uncover one.
Okay, lay them out.
Possibility 1. It might reveal highly useful, undocumented operator knowledge.
This is the romantic path. The operator actually found a faster, safer, genuinely better way to do the work, and the process engineers need to study it and adopt it.
Yes. Possibility 2. It might simply conceal a fundamental design limitation from process engineers.
This is the illusory equilibrium we discussed earlier. The workaround isn't brilliant, it's just a band-aid hiding a bleeding wound in the process.
Exactly. Then we get into the deeply problematic outcomes. Possibility 3. The workaround might add unmeasured variation to the process.
Variation is the enemy.
It is. Let's say operator A has a workaround that speeds things up by 10 seconds. But operator B, on the night shift, uses a completely different workaround that slows things down by 5 seconds.
Right.
Suddenly, your cycle times are wildly inconsistent across shifts. You lose predictability, which, in a tight supply chain, is disastrous.
Disastrous. And finally, possibility 4, which is the most dangerous. The workaround might introduce an entirely new concern or hazard.
Could you give an example of that?
The source material highlights a really profound and sobering example of this in healthcare. Medical staff, such as nurses, might quietly change the administration times of certain drugs to better fit the temporal rhythms of the ward.
What does that mean in practice?
It means the official schedule says to give a drug at 2 a.m., but the nurse knows the patient finally fell asleep at 1:30 a.m. after being in pain all day.
Oh, I see.
So, out of deep compassion, the nurse decides to delay the drug until 4:00 a.m. so the patient can sleep. Or perhaps they align the drug administration with shift changes so they aren't handing off complex tasks.
It is entirely well-intentioned.
It is. It is a workaround to handle the friction of the ward's reality. But by doing that, they might inadvertently create drug interaction risks that the pharmacy carefully designed the original rigid schedule to avoid.
That is terrifying.
It really is.
It is a deeply compassionate, highly localized workaround that accidentally creates a lethal systemic blind spot. The nurse only sees the sleeping patient. The pharmacy sees the half-life of the chemical.
Exactly. And this brings us to the governing principle of this entire concept.
If there's one phrase you remember from this deep dive, we have a mandatory emphasis on this concept.
Let's hear it.
Visible does not yet mean validated.
Visible does not yet mean validated.
Just because you have finally opened your eyes and seen the workaround, just because you finally noticed the operator reordering the steps or grabbing the blue wrench from the other station, that does not mean their workaround should immediately become standard work.
You don't just erase the old manual and write down whatever the operator is doing.
No. These observations are possibilities for rigorous investigation. They're starting points, not established findings.
I think about it this way. If you walk into a restaurant and you see that a waiter has propped up a severely wobbly table by wedging a cardboard matchbook under one of the legs, what is the correct systemic response?
Well, the wrong response is to go into the official restaurant operations manual, flip to the section on table setup, and write a new bullet point that says, Step 5, insert cardboard matchbook under the front left table leg.
Exactly. That would be absurd. You don't institutionalize the matchbook.
You fix the length of the table.
Like you fix the uneven floor.
Oh, yeah.
The matchbook is brilliant first-order problem-solving by the waiter, but it is terrible process design.
The matchbook is the diagnostic signal that the leg is too short. It is the symptom, not the cure.
Yes. So we've talked a lot about the theory, the psychology, and the hidden mechanics of all this.
Let's make this highly actionable for the listener.
Right. We want to offer a structured, source-derived observation framework designed for you to take and apply in your own environment tomorrow morning.
This framework is an application developed directly from the field note. It is designed to discipline your mind and stop you from jumping to premature conclusions.
Which is so easy to do.
When you are watching a process and you spot what you suspect is an undocumented action, a workaround, there are 5 specific questions you need to systematically ask yourself.
Let's walk through them. Question 1. What condition triggers the action?
You need to look upstream.
Right. What is happening in the physical environment, the software, or the workflow in the exact moment before the operator deviates from the standard?
Is it a specific error code? A missing part?
Yeah. Question 2, what does the operator add?
What is the specific physical or cognitive action they are injecting into the process that isn't in the manual?
Are they making a phone call, sanding a part, rebooting a screen?
Question 3, what is the action intended to prevent?
This gets to the goal-driven nature of the workaround.
Are they trying to prevent a time delay? Are they trying to prevent a mechanical jam, a safety hazard, or simply personal physical discomfort?
Yes. Question 4, is it repeated?
This separates the anomalies from the embedded hidden factory.
Is this a one-off improvisation because someone accidentally dropped a box of screws? Or is this an embedded daily habit that happens every cycle?
And question 5, what part of the process now deserves investigation?
Based on the previous 4 answers, where is the actual root cause living? Is it in procurement, software design, ergonomics?
To organize this in real time, we invite the listener to use a method to literally structure their notes. If you are conducting an observation, mentally or physically, if you have a clipboard or a tablet, divide your page into 3 distinct columns.
It's a very simple but incredibly powerful 3-column method.
Let's break down exactly what goes into each column because the discipline here is what makes it work.
Okay.
Column 1 is titled Observed. This column is for facts only. This is exactly what physically happened in time and space. No assumptions, no mind reading, no guesses about motivation, just the mechanics.
Give us an example.
For example, the operator walked 10 feet to grab a blue wrench, used it on bolt A, and returned it.
Perfect. Column 2 is titled Explained by the Operator.
Explained.
This is where you record their rationale. This is the data you get when you ask our central question, what do you do here that is not written down without accusation?
You simply write down their quote.
Exactly. The operator stated the blue wrench provides better torque than the standard issue wrench provided at the station.
And finally, column 3 is titled Inferred by the Observer.
This is where you are finally allowed to put your hypothesis.
This is where you attempt to identify the underlying systemic design flaw, like inference. The standard issue toolkit lacks sufficient ergonomic tools for the required torque specification of this specific bolt.
What's fascinating about this 3-column structure is how it fights against our own psychology.
It forces you to slow down your thinking.
As human beings, we are relentless meaning-making machines. When we see something, we instantly want to jump straight to the conclusion.
We do.
It is incredibly difficult in practice to separate what we actually see, the raw observation, from what we assume about it, the inference.
It really is like being a detective.
Exactly like that.
A good detective doesn't walk onto a crime scene, look at a broken window, and immediately write down the suspect's motive in their notebook.
Right, they write down the location of the shattered glass, they measure the window.
You have to earn the right to make an inference by establishing an unassailable foundation of observation first. This framework forces you to park your assumptions in column 3, keeping column 1 purely factual.
If we pull all of these threads together, it leads us into a much broader, almost philosophical implication about how we build the future of work.
Tell me more.
We want to connect the specific, granular lessons of this field note to a macro theme called Machines with a Human Purpose.
Okay, this is where we get into the really deep analysis of systems design. We need to look closely at what we can call the human gap.
The human gap.
Yes, and we're drawing this specific analysis directly from the text of the field note.
Right.
The reality of modern industry is this. A beautifully engineered machine or a highly sophisticated software platform may perfectly satisfy its formal specifications on paper.
It passes every rigorous engineering test in the lab.
It meets ISO standards.
Yeah.
But when it is deployed in the real world, it almost entirely relies on a human being to supply the missing interpretation, the recovery from unexpected errors, or the complex coordination between different automated steps.
It comes down to the fundamental difference between a closed system and an open system.
Okay, break that down.
On paper, in the lab, the machine is a closed system. It takes input A, applies function B, and produces output C. It is mathematically perfect.
Right.
But in reality, the factory floor or the hospital ward is an open system. Dust gets into the optical sensor.
The raw material supplied by a new vendor is a millimeter thicker than specified.
The power grid fluctuates. The machine, no matter how expensive, cannot adapt to those unprogrammed real-world variables.
The human being is the ultimate, flexible, general-purpose adapter. The human closes the gap.
Let's visualize this concept, because the source material provides a brilliant, almost tragic conceptual image.
Picture a pristine, multi-million-dollar industrial workstation.
Okay.
It is the absolute pinnacle of modern engineering. Matte aluminum finishes, glowing touchscreen interfaces, perfectly radiused corners.
It looks completely self-sufficient, like a spaceship.
But if you walk up to it and look closely right down at the floor, you see a neatly folded piece of brown corrugated cardboard wedged under 1 foot of the machine to keep it level on an uneven concrete factory floor.
It's a stark, almost absurd visual contradiction. You have millions of dollars of engineering resting on a piece of trash.
Exactly. The machine appears completely advanced and self-sufficient, but that small, low-tech human workaround, a piece of garbage, essentially is doing the real structural design work.
If that cardboard wasn't there, the machine would vibrate, the delicate tolerances would be thrown off, and the million-dollar output would be ruined.
The cardboard is holding the entire illusion of the perfect machine together.
And we need to keep this strictly rooted in the provided text. We aren't going to expand this into unsupported speculation about how artificial intelligence will eventually solve this, or how advanced humanoid robotics are the answer to uneven floors.
Right. Our focus is entirely on the role the human is playing right now, today, filling the gaps of a formal system.
No matter how advanced the machine is, the human operator is currently acting as the unpaid, undocumented process designer, bridging the gap between the sterile lab and the chaotic real world.
The cardboard wedge isn't a failure of technology. It's a failure of assuming the real-world floor was perfectly flat, and a human being stepped in and fixed it.
So as we bring this deep dive to a close, let's summarize the central transformation we hope we've achieved for you over this discussion.
It is a fundamental shift in perspective. When you walk into your workplace tomorrow, whether that is a manufacturing plant, an office building, or a clinic, you are no longer seeing a workaround as an individual's quirky habit.
You aren't seeing it as a compliance failure or a lazy shortcut or an operator just being difficult and refusing to follow the rules.
You are seeing it as vital diagnostic information.
It is telemetry. It is hard data about the complex relationship between process design work as imagined and performed work as done.
It is the minority opinions submitted by the operator's walking route.
It is the matchbook under the wobbly table.
It is the folded cardboard under the million-dollar machine.
It is the exact physical location where your supposedly perfect system is crying out for help.
Recognizing this requires a profound sense of humility from leadership, from engineers, and from design teams.
It requires accepting that their blueprints are flawed.
And that the frontline workers are quietly expending their own energy to hold it all together.
But once you accept that reality, you unlock an incredible reservoir of improvement. You stop fighting the workers, and you start fighting the friction.
We want to conclude this deep dive by leaving you with one exact governing idea to mull over. Something for you to take into your next management meeting, your next floor walk, or your next system review.
Keep this single thought in the absolute front of your mind.
Do not ask only whether the process runs. Ask what people must quietly add to make it run. What undocumented action would disappear if your process were redesigned properly?